Welcome to Data Science 1, Probability, Working with Discrete Distributions, Part 2. All right, so we've been playing with these distributions, and we know about Bernoulli, binomial, geometric, negative binomial, and Poisson. If you're not familiar with these, you should go back and watch the previous videos. Also, you should know briefly something about probability distributions in general. So if you're unfamiliar with those, go back and watch the videos, then come back to this one. All right, so what if we have something that's difficult to calculate? For example, a mobile phone case manufacturer wants to know how strong his cases are. One of its experiments is to drop the phone with the case from 3 meters and record whether or not the phone is broken. Since they have limited phones, they repeat the experiment until the phone breaks. Hence, they are looking for the number of drops from 3 meters before the phone breaks. Specifically, the manufacturer wants to know what is the probability that the case/phone will withstand more than 10 drops from 3 meters. So X is the number of drops before the phone breaks. This is a geometric experiment since it is a count until it is a success. Hence, the probability that we're interested in is the probability that X is greater than 10. All right, so that means I have to sum up from 11 to infinity of the probability X equals little x, which is equal to, from X equals to 11 to infinity of 1 minus P to the X times P. And that could be fun, but what we can do is rethink how we do this. To solve the problem, think about what we know about probability distributions. Number one, they're always positive, and number two, and more importantly, they add up to 1. Okay, and this we can use. So instead of looking at this directly, as we had before, probability X is greater than 10 is also 1 minus the probability that X is less than or equal to 10, which is 1 minus the probability from 0 to 10, the probability X equals little x, which is 1 minus the sum 0 to 10 of f of x. Plug this in, which will take a minute on your calculator, but you can plug in the numbers that we had, right? We think the probability of break is 0.08. And if we did that, we can look to see how we can calculate this. Just plug in the numbers. It comes out at 0.3996. Now, this was much easier to calculate than the infinite sum. It did take some effort, but it's really not terribly difficult. It's just a matter of what I would call plug and chug. That's an English phrase, which means you just plug everything in and you crank through it. All right, so suppose Marie is managing nurse at a small rural hospital, and she's interested in the number of people who come to the emergency room seeking care. It's about 2, and the staffing reflects this. She's worried that having too many patients come to the emergency room on any day with more than 5 patients will cause a problem. What is the probability that she sees more than 5 patients on a given day? Well, notice we kept saying day. There's a time element here, and it's the count per day. So this is a Poisson experiment with mean too, right? We said that people come to the emergency room in a rural hospital is about 2 a day. So we were interested in the probability that X is greater than 5, which is the sum from X equals 6 to infinity of the probability X equals little x. And this is just too difficult to attempt. But if we look at the complement, like we did last time, we can easily calculate this. Well, I won't say easily calculate this. This is still one of those, you plug things in and you just crank through it. But at the end of it, you'll see the probability is 0.0168. Hence, the probability is pretty small that on any given day that you'll see more than 5 patients visit the emergency clinic. Okay, so again, we've been playing with these probabilities. Probabilities just add up. And if the computation seems to be a little bit daunting, you should ask yourself, will the complement make this any easier? Because often it does. You don't always have to hit it head on, come from the complement side, and often it'll make your life a little bit easier. Okay, and notice that knowing that the densities will add up to 1 is so helpful in this because we can also use it to look for errors. But we're going to move on to talking about more properties of probability distributions in the next video, so see you there.